All right. So today we are moving towards. I think we did critical angle, we did total internal reflection, and now we are going to go for this question. Now, in this question, it says that figure 6.1 shows an empty container and an observer's eye. There is a small coin at position O. The observer is unable to see the coin. All right. The reason it says the observer and the coin stay in the same position, observe, and it is filled, like they fill it, and the container is filled with water. The observer can now see the coin. Now, if it is filled with water, like you fill it with water like this, look like water. So what happens is that because now from the water you can make a normal line, and it's going from, the rays are going from like more dense to air, which is basically less dense. So it's gonna bend, the light is going to bend towards the observer eye. Do you guys understand this? So we're gonna say light moves from denser medium to less dense, so it bends away from normal due to refraction. All right, any question, please let me know.
No.
Okay, now then it says state the name of the wave process which occurs as the light passes from water into the air. So that's refraction. All right, that's good. Explain why the image of coin is a virtual image. Now, the reason why it is virtual image is because you guys need to understand that the image only forms, like image only forms when the rays meet. Okay, so the rays go like this. You can make another ray. Let's change the color to do that. So another ray goes like this, and now you can make a normal line here, and it will also bend away from normal like this. But if you notice, the rays do not meet where the eye is. So I would basically think that the rays are coming from this point and not this point. All right, so that would mean that we can write that the rays do not meet at the screen, all right, or at the eye. So that's why that happens. Then it says state the speed of air, which is 3.0 times 10 raised to 8 meters per second. Now, this concept that I've just told you, well, they're not going to ask you this, but you should remember that the coin was here and the coin seemed here, which means this is the apparent depth. Apparent depth means that it's not the real depth. When you look in the swimming pool, you might also see that it looks shallower than it really is. Is it clear?
Yes, sir.
Okay.
Clear.
Okay, that's good. That's good. Okay. Then it says the refractive index of water is 1.3 and calculate the speed of light. So you guys know that refractive index, the formula is speed of light in air or vacuum, okay, divided by speed of light in medium. So this is our formula. Refractive index is 1.3. The speed of light in air is 3.0 times 10 raised to 8, and we want to find the speed in water, right? So let's call that V. So 3.0 times 10 raised to 8 divided by 1.3. Can you please tell me what is the answer?
Two point three one into 10 power 8.
10 power 8. Very good. 2.3 into 10 raised to power 8. And you got to write the units with it, which are very important as well. All right. Caroline and Smiley and Iman and Yusra, you guys understand this?
Yes, sir.
Zainab Hussain,
Yes.
Shawis. Okay.
Sir, can you explain the A again for this question?
Part A,
Yes, sir.
like the whole thing, all parts.
Yes.
Okay. It says why coin can be seen, because originally it was empty. Like I'll draw it like this again. Don't worry. Oh. Okay. Originally, what the thing is, it's empty, right? So the rays are going straight like this. So the eye cannot see. Do you understand? So when you
Yes, sir.
fill it with water, what happens is that if the ray comes to the water and now you draw a normal line because it's going from water, which is basically more dense, to air, which is less dense. So I told you that when it goes from more dense to less dense, it bends away from the normal. So when it bends, the eye can see. Do you understand?
Yes, sir.
Okay, Shavis. Then the next thing is that's what I've written. The light moves from more dense to less dense and bends away from the normal, so due to refraction. Then says what is the wave process? That's refraction. Explain why the image of coin is virtual. The reason is that if you make another ray, like let's say another ray anywhere you can make, and you draw the normal line, so it will bend like this as well. But these rays are like sort of going away from each other, so they're not meeting at the eye. So the eye would think they're coming from somewhere behind, right? So it would seem that the point O or the coin is at this point, not where it is actually. All right, this is called apparent depth. Is it clear?
Yes, sir.
So because it is a virtual image, because the rays do not meet at the screen or eye, that's what you're gonna write. And then it says state the speed of air, that you know. Anything else?
No, sir.
Okay. Now sometimes what happens is that you also see partial reflections. Okay. So even if in the same medium, let's suppose a ray is coming up like this, right? And this angle I is even greater than critical angle. So some of the light will go like inside, like it will be totally internally reflected. But some light also escapes outside like this because ray have different densities. So this portion that you see here, it's called partial reflection, and partial reflection means that not all of the rays totally internally reflect. So some may refract. And the reason is that you guys need to understand that if I, the angle of incidence, is very very close to C, then this phenomena happens. So sometimes you might see that during the night time you're looking outside the car window, and then you also see your face as well, because that's partially reflected rays. All right, is it clear? Although it's not a mirror. Okay. Now, so like for example, in this question, okay, please write this down, then we're gonna go forward. Okay, Saleh, why are you late? Did you forget about the class?
No, sir. The thing is, I have finals, so I didn't pay attention.
Oh, okay. All right. So then we're gonna go towards the next question. In this question, it says that the refractive index of diamond is 4.2, and we got to calculate this angle. Right now, we should understand that it is going from basically air to diamond, right? So when it goes from less dense to more dense, you got to use which formula? Who can tell me with respect to angle? N equals
Equals to sin I by sin r.
sine I over sine R. Very good. So we got 2.42. Sine of I is 40. Oh, my bad. Sine of R we got to calculate, because this is 90 degrees. So it's 40 minus 90. So it's going to be 50. Alright, do not make the same mistake. So it's going to be 50. Very clever of them. And then divide by. So angle is always taken, like I just want to, emphasize here that angle is always taken from normal line to ray. It is not taken from the object to ray or something like that. And then you got to divide by sine of r. So sine r will be sine of 50 divided by 2.42, and then you can find r. So you can use the calculator like this. Sine 50 divided by 2.42, and then you can take sine inverse of the answer, and that would be 18.5 degrees. All right, is it clear, everyone? Any questions here?
No.
No.
Then it says what is meant by the term total internal reflection. Now for 3 points, what you want to write? You want to say point one, when ray is passing from more dense to less dense medium. All right, this is very important, otherwise total internal reflection cannot happen. If angle of incidence becomes greater than critical angle, that would be the second point, the ray reflects back inside. This is called total internal reflection. So please, back inside the same medium. Okay, interjection here. All right, so that should be the 3 marks you should be aiming for. Then says the angle y is greater than the critical angle of the diamond. Where is the angle y? This one, see? So it says draw the path through it. So if it is greater than the critical angle, then obviously your ray should be exactly like this. And one thing you want to scale. Is it clear, everyone?
Yes.
Okay, so that would give you 2 marks. Very nice. And then we're gonna go towards the uses of total internal reflection. So first use of total internal reflection is optic fiber. Yes, Imal.
So we have to go out of the present only.
No, just at
So
pointer.
the question asks for
Question asks, draw the path red light through and out. Oh, okay. So you can just red light through and out. Oh, okay. So you can just take it out like this. You have to go, you have to draw a normal line and then bend it away from normal like this, bit away. Because it would go out, the reason is that, and bend away because if you see this angle is much less than this, so it is quite possible that it is just normal refraction, a refraction afterwards. All right, is it clear, Nawal?
yes.
Okay, then it says in this uses of total Turner reflection, it says continue the path. So in optical fiber, now in these sort of questions you got to make 3 reflections, and these will be like there all the time, so you guys need to remember. So how to do that? You make a normal line and then you make a reflection. Usually it would go beyond this, I don't know. All right, just make it through the eye if it is possible, right? Make 3 reflections. If it's not possible, just it's all right, like this. But the thing is that this angle I, this R, this angle I and R should be same, and it should keep on going like this. Is it clear?
Yes.
Then it says the refractive index of a material of fiber is 1.46. Calculate the critical angle of material fiber. Now critical angle formula, who can tell me the critical angle formula, please?
N equals to 1 by sine C.
Sine C equals to 1 by n. Very good. So we got to find 1 over 1.46. How do we do that? It's very simple. All you need to do is you got to put shift and sine. It would give you sine inverse and then the value of 1 divided by 1.46. And that's not fair. 1 divided by 1.46, so that is 43.2. Write that down, degrees. And then it says state 2 uses of optical fibers. So usually optical fibers are used in communication. Communication is the fast internet, right? And it is also used in medical use, like endoscopy. Endoscopy is basically something that causes you it basically, a camera is sent to your, like, from your mouth or nose, and then they can view inside if there's a problem inside a human body. You guys know about that?
Yes. Yes.
Okay, so that would be something like this, right? So if you have any questions, please let me know, and then we're gonna go forward. Okay, very nice. So then we are gonna go towards the next part, which is reflectors of light. This is also a use of total internal reflection. Light reflectors are basically, you might have seen, let me just show you quick. Light, oh my goodness, why won't you do that? Light reflectors on cycles. Okay, usually they're more prominent there, but have you guys seen this?
Yes.
Yes. Okay, so these are light reflectors, and why they're so important is because they reflect light of any car that is coming from behind it. And how do they do it? Basically, they uses plastic or glass usually, and then when the light from like a car or something is incident on you, so it goes straight, like for example this light is coming, so here it reflects back like here, and then it totally internally reflects, and then you make a normal, and then it reflects back. This way the incoming car gets an idea that from its own light that something is ahead. Do you guys understand this? So this is how it's drawn. Like that. Okay. But yeah. All right. Is it clear, everyone? Any questions? Okay, then you have the same thing, like optical fibers can also be used in medical use, and generally they will have a specific question about it, but we're gonna do it like one by one. So it says optical fibers made of glass that refractive index 1.2. State the name of process that occurs at P and Q. So that's obviously, who can tell me what that is? I don't know. Go on, hurry up. Which process is this? Yes, very good. That's total internal reflection. Excellent. That says calculate the minimum value of I for which there would be no refraction at point P. That would be the critical angle, right? So it's asking about the critical angle. We're going to use this, and sine C equals to 1 upon 1.4. Can you please find this value?
$45.6.
45.6. Okay, so that would be the minimum value where internal, like it would not refract nor reflect inside, it would just go parallel to that. And then this is the question I wanted to target, right? In this question it says that in this question it says state and explain the use of optical fiber in medicine. And this question is generally, it would come like a lot of times. Okay, so one by one I'm gonna help you write it down, and then you guys can learn what are the points that we need to figure out. Okay, so the first thing is so wait a second please. Anyway, so where were we? Okay, fine. All right, I'm back. Now let's start. First of all, we're gonna say point one. You're gonna write that the optical fiber is inserted optical fiber is inserted into a human body that needs to be examined. All right. The light pulse is sent into the fiber that reflects off the targeted area, right? Or basically whatever you're basically looking at, right? Third point, multiple lights are then computed to form an image of illuminated, you can write organ, area, whatever you want to write, all right, like this. Is it clear, everyone? Let me know if you need help with this. All right. Okay. Zahra, Iman, Smiley, and Amal, Yusra, Zainab. You guys understand this? Zain, very bad. And Shavez, Saleh, Hussein. Everything is clear?
Yes, sir, teacher.
Okay. Caroline, everything is clear? All right, very good. And then it says the ray of light is monochromatic light. State what is meant by monochromatic. Well, mono means single, right? Chroma means color. So when you're talking about single color, we're gonna do this later on as well. But I just want to tell you that it means light of a single frequency. That's what it means. All right. If they do not give frequency, you can write wavelengths. Okay. So please do remember that. Okay. Then you also have periscope. Periscope is a device that can help you look at things which are higher than your height. And this sort of periscope where this person is looking across like the wall, like above the wall, and obviously he can't see it from directly, so he uses periscope. So first of all, it says complete the origin. So what you do, you're gonna continue with the ruler, you're gonna go straight, and then from there you make a normal line, and then at the same angle you're gonna reflect it back to the other periscope like this, and then you got to make the next normal line here, and then it is going to get totally reflected to the eye of the person like this. Okay, so that's how periscope works. So it says show that the refractive index of glass with the critical angle of 45 is 141. So we know critical angle is sine c over 1 upon n. Sine c is 45 and over 1 upon n. Can you guys please find n, please?
Say that's the value 1.414.
Okay. What, that is the value, right? 1.41. Okay, that's cool. All right, give me like 1 second, please. All right, now I'm going to the next, and that's it. Oh, we're done already. That's very cool. So we're done actually for light, and I think tomorrow when we start with optics, we're gonna clamp it with, because optics super easy, so we're gonna clamp it with the electromagnetic waves. So one day saved, and then we're gonna move towards sound. All right, if you still have any questions, do let me know. I am basically posting this because there's a lot of drawings, and I understand that it is quite difficult for you to do it like on the go. So I'm just sending this page to you on the Google Classroom as well. Rest of it you need to complete, obviously, that you guys know how. All right, so second please.
So we're done with the class?
Yeah, unfortunately it's finished. Hey, you guys want to do question paper 6 for 20 minutes at
Yes.
least? Okay, let's go. Let's do paper 6, huh? Wait, let me see where light started. At 176 to 193. 176. 176. 176. Okay, perfect. And that goes to Google Classroom. I hope it loads to. Okay, fine enough. All right, so let's do now. Yeah, IG exams. My keyboard is not working. I don't know why it's doing that to me. But never mind. I think I need a restart. Light. Sorry, IG exams. Alright, so we're gonna start this today, and we're gonna try to do some parts of it, and then whenever we get next time, sometime we're gonna do it again. So we're gonna looking at paper 6 right now of extended one, and let's do 2021 easy paper. All right, so okay. So what you're gonna do is you're gonna basically, this is a very simple question, simple paper, requires a little bit of understanding from the lab, but I'll help you understand this a bit. So you got a force meter, and they've said there's a loop of thread 90, and then there's the pivot, and then there's a weight where it is. So first of all, they say calculate the value of L, readings taken from figure 1.2 show your working clearly. So you're gonna see where the weight is. So we want to find basically the center of this to the pivot, okay? And the pivot, I don't know, it is at 10 centimeter mark, okay? So the center, how would we find center? You're gonna basically use your ruler and try to mark it like this, okay? In the exam as well. And then also mark it from here in the exam as well. So if you read it, this is going to be 23.1, 23.2, 23.4, 23.4, and 23.5. All right, so 23.5 here, and then on this side it's going to be it's 27 written here, so it must be 26.9, 26.8, 26.7, 26.6, and 26.5. which means that this whole distance that you're looking at has to be, I think, 3 centimeter. You guys agree?
Yeah.
So that also means,
Yes.
yeah,
Sir.
yeah, yes, please. Your question? Okay, and you would also agree that this basically whole thing, like, because the diagram says at the center of this, center would mean that we are looking at from here 1.5 centimeter. Okay, now the issue is that they say calculate the value of L, which is from the pivot, which is at 10 centimeter, and this is right now we got to know this is 23, oh my goodness, 23.5 plus 1.5, what is that? I think 25, right?
Yes.
Yeah, so 25 minus 10 is, it is basically 15.0 centimeters. Now if you notice, I've written 15.0. Why I have written 15.0? Because it shows the precision of the instrument, which is right now the meter rule, which means this is like 1 decimal place correct to precision. Is it clear, everyone?
Yes.
Okay.
Sir, why L 15?
Why is 15? So I know that I found where is the center point here. It was 1.5 from 23.5, right? So it means this point should be 25. You agree?
Yes, sir.
And because this point is 25, I want to find this L, which has to start from 10 centimeter, because there was 10 centimeter mark. So I have to go like this, 10 minus 25, 25 minus 10, sorry. You get it?
So L is 10 centimeters away from the stand?
Yes, it is shown on the diagram, as you can see. It says the pivot is at 10 centimeter mark. This is 10. That's 25. So we got to find L. We got to subtract them, no?
Yes, sir.
Do you understand now?
Yes.
Okay. So then in the next part it says force meter. Read the value from force meter. Now, if you see, this is also correct to 1 decimal place, and right now it's like 1.1, 1.2, 1.3. So it's going to be 1.3. So I'm going to write 1.3, and that's it. And then explain how the student makes sure the ruler is horizontal before taking the reading. You can take. Now there are a couple of things. Yes.
So can we say to use a set square?
Yeah. So generally that's what we do. There are two objects that we use. Whenever you want to check the level of something, level of anything, then I just want to tell you there are two things. Number one, there is called a spirit level. Spirit level. Have you guys seen spirit level before?
No, sir.
Okay, spirit. Yes, it is basically like something like this with the air bubble inside. So bubble basically makes it, like you can put it and the bubble moves.
Oh, yes.
You guys have seen this, everybody? Or should I show you the picture of spirit level? So you can write this. You can say I'm gonna put like I'm gonna use, don't write I'm going, sorry, do not write the student can use a spirit level. Alright. Also, if you want to put a set square, that is also right. But for set square, you need a reference as well. You need reference. What I mean by this is like your ruler. So if this is like vertical stand, so you got to put the set square like this to make sure it's horizontal. Do you guys understand that?
Yes, sir.
So you can write both, and then you can draw the drawing of both of them on the ruler. That would help you. Okay. All right, Iman, do you understand everything? Saleh? Okay, very good.
Yes, sir.
Sorry, Vizainab?
The name is spirit ruler or spirit line?
Spirit level. Spirtlevel. Obviously, when you solve these papers, these are not like physics teaching, it's more like solving as many papers as you can, and then you can learn from me what kind of instruments basically we're gonna use. Okay. Anyway, now we are just running out of time, but before we go on, I just want to tell you a few things, and then in the next class we're gonna continue this. So when it says that you got to plot and you got to start the origin, and it says you got to plot a graph and blah blah blah, the first thing you should always remember is that you're gonna put labels of quantities and units, which means that if f is in y-axis, you're going to write f slash the unit of it, and L slash the unit of it. Is it clear? Then the next thing you're going to do is you're going to put the make sure that you use maximum graph area possible. All right, do not make graph this small, please make it big. So how do we do this? We have, like, you have to start from 0, but you have to end at 60, and we got 1 2 3 4 5 6, and that's very good. So we're going to start from 0, and then we go 10 and write the same process: 10.0, 20.0, 30.0, 40.0, 50.0, and obviously 60.0. So now we're using like the maximum graph, and then here you got to start from like 0 but end at 2.45, and if you look at this, they have like a difference of the same, right? Now upward scaling is really bad, like you shouldn't take 0.33, 0.222, 5.6666. Do not take like this. All right, you have to take normal numbers. So let me tell you how. So you got to go to 2.45, and we got like almost 2.50, and we got 1 2 3 4 5 boxes, right? So what we can do is, I think we can manage it in like 0.5 every time. So like, for example, let's take it 0.5, right? 0, let's take it 1.00, 1.50, 2.00, and 2.50. Do you guys agree? Do you understand how I did this?
Yeah.
So I've used the maximum space just to, make sure that everything is big enough. And then the third thing, you should never put blobs. Now what are blobs? This is very important. So for example, if I want to put like, I want to plot 20 and 1.35. So what people do is they go on 20 and they say, okay, this is 1.25. So I think this is 1.25. So I don't know how many boxes. So each box has to be, I think, 0.05. So 1.25, this will be 1.3, 1.35. So this will be 1.35, right? So what people do is that right now, what you should do is just make a dot and put a circle. Or alternatively, you can also make a cross like this, a small cross. Now what people do is they try to make bigger circles, like they would make a circle that is this big. Now on my scale, it doesn't really make much, because I can zoom it in, but generally people would do it. Now what is wrong here? This is called a blob, and blob is something that is bigger than half of the smallest box. Do you guys understand that? So if you look at from the actual scale, this would be your actual scale of the paper. So you might see how big it is, and this is so small. So you got to make sure that you do not put blobs. Is it clear, everyone? Because this is not an art class, this is a physics class. Now,
Sir,
yes.
do the graphs have to be ruled or like freehand?
No, it depends what kind of graph it is. If it is like, if it's a curve, then it is a freehand. If it's a straight line, then it has to be ruled. Okay.
Sir, and if it's like directly proportional? or inversely proportional, then we draw a line of best fit.
Yeah, you draw a line of best fit anyway. I'm just going to tell you what that is. But the thing is that if it is directly proportional, so in case of directly proportional, you guys you have to start it from 0 and 0. You have to start the line from there. If it is just proportional, then there must be some y-intercept. All right? Because that's how it works in maths. All right. Anyway, so what exactly is a line of best fit? Let me just quickly, demonstrate it. So I'll draw a couple of things. 1.3, 1.35. So this is 1 point. And then we got 30 and 160, 1.60. 30 and 1.60 will be 1.55, 1.5, 1.6. So this should be 1.6. And then it says 40 and 1.90, 40 and 1.9. 1.9, where is 1.9? I don't know. 1 point, this is like, this should be 1.9 because this should be like 1.95 and 2, like this. And then you got 50 and 2.15, 50 and 2. This is 2.0, 2.1, 2.15. Seems like a straight line to me. And then 60 and 2.45. 60 and 2.45 is going to be 2.45 is going to be here. All right, so this is a line. Now when you do this, then what are the main misconceptions about best fit? So best fit is basically two things should be true for best fit. One thing is that the best fit line should have equal points above and below it. So this is one of the things. And the other thing is that points must be close to each other. Now most of the teachers, they tell you not exactly the right thing, and that is what is misconception is, they say most of the points must be on the line. All right, this is a big misconception. Never ever do this. What you should understand is that even if none of the points come on the line, it's okay if you have these two rules being followed. Like for in this, we have there's only 5 points, so one has to be on the line. So I'm going to make a line like this, and the line should be closer to all points. So in the actual exam, I would have drawn something like even better, something like closer. Okay, keep doing this unless you're like really close to all points and the points are sort of equally divided. Right now they're not, so I'm just gonna move it a bit again. Okay, so now my line has 1 point on it, like you can see here, and the rest of 2 points are on top of the line, 2 points are below. So this is a perfect example of a best fit line. Is it clear, everyone? Please let me know if you have a question here.
No question.
Good. If all points are coming, all right, that's good, but that's not necessary. So obviously then from the graph determine f naught for the value of length equals to 0. So for that you just need to oh, it's not picking up my line again. Okay, it has now. You just need to see where you are to make a full line like this, and if you see, it intersects right here, which is basically when length was 0, f naught was 6 and 0.65. So we're gonna write 0.65 right here, and then it says calculate the weight of the meter rule. Equation is 2 equals to this, so weight will be 2 times 0.65, and I think it's gonna be 1.30, like that. Okay, so I hope you guys understand something out of it, and also the graph rules and stuff, which is the most important part of this whole thing. And I will see you in the next class then. Have a great day.
Sir,
Yes.
for extension, we have to always start from the origin, right?
For extension, for what? Sorry.
For extension, the force
Yeah,
of
yeah,
extension.
yeah. That's true. That's true.
Sir,
Yes.
do we have to make the circle around the points?
If you're putting a dot, because sometimes dots are very light and exam might not see that, so you put a circle. Otherwise, you can just make a cross if you want to. That's also fine. All right.
Okay, sir.
All right, then that's pretty good. So I believe I will see you in the next class then.